Okay guys, so in this video we're going to be graphing the cosine and tangent functions. Before you watch this, you might want to watch the video I did right before this. So it's just going to be called Graphing Trigonometric Functions Part 1. And it's the video right before this. So you might want to watch that first. But anyways, in this video we're going to be graphing cosine and tangent functions. Okay. So let's graph cosine now. Well, we know what all of the triangles look like, so this should be a little bit quicker. So what about when we start? Well, when we start, we know we're going to have this horizontal line, right? Because we're going to have an angle of 0. But that is actually going to mean that the adjacent over hypotenuse is going to equal 1, okay? I'm going to start at 1. And that's because the adjacent side is the bottom side, right? And the hypotenuse side is the longest side. So we're basically reaching a point where the adjacent and the hypotenuse are equal to each other. You can imagine when these triangles I drew were getting smaller and smaller, skinnier and skinnier. While the opposite was getting smaller and smaller, the adjacent side, which is over here, was getting, the adjacent side was getting longer and longer until it eventually equaled the hypotenuse. And we know two things that are equal, they divide to get 1. So at first it will be 1. Okay, what about pi halves? Well, pi halves, we're going to have a vertical line, right? Let me actually just make some space. Okay, at pi halves, we're going to have this vertical line, right? That's not a line. Vertical line. And while the opposite side is going to be really big, the adjacent side is going to be non-existent, right? It's just going to have a length of 0, right? This vertical line. So it's going to be 0. And you might see a pattern arising. But I'll keep going just in case. But at pi, 180 degrees, we've gone all the way around, right? Now, like the opposite side is negative when it goes below the x-axis, right? The adjacent side is going to be negative when it goes to the left of the y-axis. So once it reaches this point over here, once it reaches this point, this area, this left side of the unit circle, it's going to be negative. So we're going to get the value -1 because we've gone, well, I'll just do this. Circle, okay. We've gone all the way 180 degrees to get this horizontal line, but it's to the left of the y-axis, so it's going to be negative. It's going to be, so it is going to be, it's going to have the same magnitude as the hypotenuse, but it's going to be negative now. So we get -1 divided by 1. This is the hypotenuse, this is the adjacent side, okay? And we end up getting -1. So we can graph -1 here. Hopefully this isn't getting too messy. 3 pi halves is going to be another vertical line, so it's going to be 0. Okay. 360 degrees, we're back where we started. So we're going to be back at 1. Okay. And then we'll just continue like that. So it'll look something like, ooh, that's not, it will look like this. Oh. Well, this is not the greatest drawing, but hopefully you kind of get the idea. You can look up graphs as well for better drawings, but this is just to kind of give you a feel for what these graphs actually mean. They really are just connecting the side length ratios of a triangle to its angle as the angle changes. Okay, so let's just graph tangent. So at the beginning, we start with a horizontal line. We know it's opposite over adjacent, and in this case, we know the opposite is 0, so it's going to start at 0. Okay. I should probably label these, shouldn't I? So this is cosine. This is sine. Okay, and then I'll do tangent. So it starts at 0, right? And then it is going to And then once it goes to a vertical line like this, a vertical line over here, which is 90 degrees or pi half radians, what are we going to be then? Well, it's a vertical line, which means it's going to be opposite over adjacent, which is going to be a fairly large number, right? Because you can imagine the opposite side over here is 1. It's going to be at its height. It's going to be the biggest it could possibly be, while the adjacent is going to be 0. Or it's going. So what this is going to do is it's going to approach a really, really, really large number. Okay. So we're approaching this really, really large number. So it's sort of like approaching infinity. But you can imagine the opposite side is getting really big, the adjacent side is getting really small. You're going to get to this really, really large number. Okay. And then once you go past this point, right? Past this 90-degree point, what is going to happen? Well, what's going to happen is your adjacent side is going to become really, really small. Your adjacent side is going to become negative, right? Your adjacent side is going to become negative because you've passed this y-axis, right? So if your adjacent side is now a negative value in length, your tangent is going to be negative as well, right? So right after this, let's say so I'll use this unit circle now, this one. You were at 90 degrees, right? Then right after, or at that point, right? Because we're just passing the 90-degree threshold. Our a is going to become negative, right? So now we're going to be all the way at this negative point, right? And it's still going to be like a really, really small, now it's going to be a really, really low value, right? Because we still have a really, really small adjacent and we have a really, really big, or like a big opposite side, right? So it's going to be really, really small. And what's going to happen, I'll just draw it a little further up to make it nicer looking. What's going to happen is we are going to manage to approach. So we're going to start from this really, really low value, and then as the angle increases, we're going to get a less low value, right? Because the opposite is getting smaller and the adjacent is getting bigger, until we eventually approach 0 at 180 degrees. Okay. And I just want to make something really clear. At this 90-degree point, we're passing through the y-axis at this point. Okay. So at this pi half point, at this 90-degree point, we're going to have two y values at that point. Because there are two possibilities. You could either take the adjacent as negative or positive. And this might be a bit hard to visualize, but we have a really, really small a, right? So we have a really, really small a. So when you approach it from this side, right, as these triangles, right, these triangles get taller and taller, your tangent is going to get really, really big, right? But then at this 90-degree point, there are going to be two possible values, because you could either consider a to be negative or positive, because you're passing through this y-axis. So you can either have a really, really high positive value, really, really large positive value, or really, really large negative value. Okay? So we're going to see a bit of overlap in this function because there are going to be 2 points at this pi half point. And then what's going to happen after this? Well, it's going to do the same thing as before. Okay? Because you can imagine you're at 270 degrees now. So you've gone to this side. And now our opposite is also going to be negative. So because we passed this 180-degree point, now both our opposite and our adjacent are negative, and we know a negative divided by a negative is just a positive. So that's why we're getting these positive values on the y-axis. okay? Until we reach this point, right, where our adjacent will become positive, right? Once we reach this 270-degree point. And our adjacent's becoming positive, so what's going to happen is now we are going to, this graph is going to become negative again. Because a negative divided by a positive is a negative, because the opposite is still negative. So we're going to go back down and we're going to do the exact same thing as before. Oh, sorry, I sort of have to draw on this unit circle. And then we're going to repeat the same pattern as before. Okay? And you might sort of start to see a pattern, but basically for the rest of the graph, we're just going to have all of these sort of curves. They're all going to look the same. So yeah, so that was graphing all of these different functions, these trigonometric functions. But really, when it comes down to it, is basically you just need to think of the unit circle as a tool that you can use to find out what triangles look like when you are plugging in different angles. It can be a bit daunting, or it was daunting for me at least, when I was plugging in different angles and I was getting triangles that didn't even have that angle inside of them, right? Because really what trigonometry is referring to sometimes is the unit circle. For example, like 120 degrees does not fit inside of a triangle with 90 degrees, a 90-degree triangle, a right triangle. So what we do is we represent that triangle using this unit circle. And using this unit circle, we can actually graph these trigonometric functions. So that pretty much concludes this video. Thank you.